Okay. Safety issues are a pretty big thing when it comes to electricity because, yeah, as you'll see in the last slide of the deck, it doesn't really take a lot to do you some harm. Um, the convention in household wiring in the US is that hot is black, the black wire is hot, the white wire is neutral and usually connected to ground. And when we say ground, we hopefully literally mean the ground. The way we make sure that homes don't float relative to each other, just like your discussion question about an aircraft. You don't want a home building up a charge because it's isolated from ground around it so that when you step out of your house, you shock yourself when you step onto the ground. You don't want that. So if you look in the outlets in your house, um, in the outlets in your house, there are in modern outlets, you've got a large pole, a smaller pole, and this center. This literally connects to a wire that should be connected to the dirt outside your house. Now, usually that will be a copper rod that's driven into the ground near your meter or something like that. And the in some of the older homes like mine, that's more problematic because the way electricians used to do this is that they would run this and not bother going all the way to copper to the grounding rod over by the meter. They would just hook it up to a water pipe. Well, back when water pipes were copper, that was fine. But as copper water pipes, I can't really write copper here very well, as water pipes have been replaced with PVC, these ground connections that were made when electricity was first put into homes have disappeared. And so it's not a bad idea to get a little tester to see, is my outlet grounded? And then you've got your hot and you've got your neutral. Why is that important? Why is it important? We used to not have this. They used to be the same. You could plug a two-pronged outlet in any way you wanted. Well, the reason it's important is one of these, sometimes one of them, if it's the neutral, which also is supposed to connect to that. If it's the neutral, it may be connected to the outside metal on an appliance. So you don't want your refrigerator, right? An old refrigerator might be two prong instead of three prong. You don't want the outside of your refrigerator building up a charge. So you hook it up to the neutral prong on an outlet. Well, the way that worked when we had two pronged outlets and we didn't have the grounding wire is you could plug it in backwards. And now on the outside of your refrigerator, you have 120 volts instead of 0 volts. And you could shock yourself. And then you have to go over and say, oh, well, I plugged that in wrong. Okay. So we don't do stupid things like that as much anymore. Other things in this um, that you'll see, here is a GFI outlet. So a ground fault interrupting outlet, all it does is, when current goes out to your appliance, the exact same amount of current should be going back. And so all it does is compare current going out to current coming back. And if those are not the same, that means current is going somewhere you don't really want it going, and it turns off the appliance. It basically turns off the outlet. You'll see these near water, and in fact, by code, anything within 3 feet of water has to use GFI outlets. Now, it might be that some of your outlets are chained together and are all off of the same GFI. You can do that, and so you might have across your kitchen counter one GFI, which is going to have the test and reset buttons in the middle, right? And then another outlet that looks like a regular outlet on the other side, and this has, the plugs. Okay, but this actually in the wall ties to that. Okay, so that's step one on safety, and I'll cover other bits.